we will try to do the next version of ANOVA. Now let me try to revisit what we have done by now. In ANOVA we have tried to do, which is something difference of mean test. What we have done yesterday was that ANOVA is something that helps us in visualizing difference between more than two groups. So when we were talking of t-test were having only two groups, and the difference between ANOVA and t-test was that ANOVA can visualize difference between more than two groups, which t could not do. So that was the basic difference between. There were some assumptions behind both of these things, and the assumptions were that t should have followed the homogeneity of variance test, all right, which means that variance between the groups that we are studying should be equal. So this is something that we have tried to do in T. The same was the case with ANOVA. In ANOVA, we also said that this is the assumption of ANOVA, wherein that variance between the groups that we are trying to study should be equal. So those assumptions were actually tested by applying Levene statistic. So Levene statistic actually was applied, and significance figure in the output of SPSS we have looked at it. And as I have reiterated in previous sessions, so whenever you see SIG, which is significance thing in output table of an SPSS sheet, that is nothing but is p value, which is probability value. And when we were doing normal distribution, we have seen what is probability value. So a probability value of less than 0.05 would mean that null hypothesis is accepted. And hence we would say that there is no difference, as null hypothesis in both these cases, be it T or be it ANOVA, is that there is no significant difference between the groups being tested. So now we then just to give you an idea what we have done yesterday, I have the same file with me that we have done yesterday to take it as an example. So we have gone into ANOVA, which is under the head of analysis, and then we have to go to compare means. In that we have to take bank branch into the factor and then weight time into the dependent list. So just to very quickly reason through it, this problem was with bank branches that a bank has, and essentially bank was trying to visualize the wait time in these three branches of its bank. So it actually was trying to study out that does any of its branches has a lesser amount of wait time as compared to another branch. All right, so which branch is more effective as far as waiting time is concerned? So for that, what we have tried to do is we have tried to apply ANOVA. By applying ANOVA, we would trying to see whatever the difference is between the wait times of three branches, was it really that big a difference that it can actually be treated as a difference? So that is something that ANOVA does. So I've repeated multiple times. So for that we have gone into descriptives, we have clicked on to homogeneity of variance test, and we have also clicked on to Brown and Forsyth. Then I have pressed continue, and then I will say okay, this is the output sheet that I will have. So if you would look at, n was representing the number of people in branch A, 91 number of people in branch B, 100 were in branch C. So these are the mean values. What mean values? Mean values of the times. All right. So 125 people who visited branch A, the waiting time which they have seen in this branch was somewhere around this thing, 5 minutes 52 seconds, right? So in branch B, the mean waiting time was 5.20. In branch C, mean waiting time was 5.1. So then we have also tried to understand the importance of standard deviation in making a meaning out of it. So as the standard deviation in case of branch A is maximum, so then we would like to say that a standard deviation of 1.3, which is minutes, all right, and mean being 5.5, that means what? If at all it is a normal distribution, then how we did it was 5.5, which is the mean value, 1.3, which is standard deviation. So 5 point range would become 5.5 plus 1.3 and 5.5 minus 1.3. All right. So if you can remember that normal curve that we were studying. So one is 5.5. So let's take this figure into Excel, and I pasted it. So this is your mean value and this is your standard deviation, right? So if I can make it like this, equal to this mean and minus standard deviation, right? And then mean plus standard deviation. So this is my range between 4.1 minutes to 6.8 minutes. This is the range of waiting time which almost 68% of visitors have witnessed in branch A. Are you making a meaning out of it? So the only logic behind it was that if I can get back to that PPT which actually tells us about normal distribution, right, then we will realize this perhaps is not that PPT. So we actually have to look at something, the PPT I am trying to come to. Yes, this was the PPT. So we would just look at the normal distribution. So this normal distribution actually tells us that a value of z which is equal to 1, right? So 0 plus 1 this side and minus 1 this side. So this becomes my range from this point to this point. So this range will have almost 68% of the people if it is a normal distribution, right? And z value of 1 means nothing but this is one standard deviation. A value of z equal to 2 means 2 standard deviation. So a standard deviation here was 1.3 minutes. So this 1.3 minutes this side, 1.3 minutes this side from the mean. This is mean, if you can remember from the properties of normal distribution. So mean minus standard deviation, one standard deviation, mean plus one standard deviation makes it this range which will have 68% of the people. So how do we make a meaning out of it is that when we look at this thing, now let's get back to our Excel. Now this becomes my range. So the number of people in branch were 125, right? So 68%. So 125 multiplied by 68, and let's make a percent out of it. So almost 85 people who visited branch A have faced a waiting time ranging between 4.15 to 6.8. So that is how we make a meaning out of it. So this is what standard deviation tells us. So similar is the case for branch B and for branch C. But here, since the standard deviation is lower, so which means that these branches has been little bit more consistent in their waiting time. All right. The more variation into branch A can also be attributed to the fact that A branch has more visitors than branch B and branch C. So as you increase the number of people, so standard deviation would also increase, because standard deviation is calculated by keeping in mind the mean values or the observations, right? And observations, more observations, there will be more extreme values. So this is how we try to do it. Getting back to our output sheet, then we had to check the assumption of ANOVA, which is that variance across these three groups, which is A, B and C, that should be equal, right? So that is checked by Levene statistics. That is something that we were talking about. This is Levene for you. So Levene statistics is giving us a significance value of 0.018, which obviously is less than 0.05 at 95% level of significance. So we will conclude that variance of these three groups are not equal, because null hypothesis is rejected here. Null hypothesis was that there is no difference between the variances of these three groups, but as it is rejected because the value of P is less than 0.05, so we would say that the variance of these three banks, at least in case of their waiting time, is not equal. And when it is not equal, we cannot go with F, right? This is your F statistic, because F give you exemplifying results when the assumption of homogeneity is not met. And in that case, as we have done yesterday, we go for robust test of equality of means. Robust tests are two, Welch and Brown-Forsyth. So now we would look at the significance values of this rather than this. So this becomes no sense here. So this makes no sense, because the variances condition is not met. That is what Levene tells us, and hence we cannot apply F. So there is the F statistic. So if you go to the recording of previous lecture, you would come to know that ANOVA uses F to calculate the significant difference between groups that are being studied. So now we will go for Welch and Brown Forsyth. But here this is one of those examples which actually gives us the first-hand privilege of seeing that Welch and Brown Forsyth themselves are giving different results. So if you would look at Welch result, then it tells us that there is no difference between branch A, B, and C. But when you look at Brown Forsyth, it says that there is difference between the waiting times of branch A, B, and C. So when I say difference, you treat it as significant difference, right? So which one to believe on? So literature talks about Welch being more robust than Brown Forsyth. So when these two tends to give you different figures, then you have to believe on to Welch. And Welch says that there is no difference or no significant difference between the waiting times of branch A, B, and C. So which means that the difference that these branches are having in terms of their waiting time can be attributed to chance only. Alright, so in probability we talk of chances. So this difference can only be attributed to chance and should not be treated as a difference which is a significant one, and should not be we should not be taking any decision on the basis of this, that these branches are having different waiting times, and we cannot conclude here that the branch who is taking minimum waiting time is the best branch. So here we cannot conclude that branch C is best because it is having 5.1 minutes of waiting time and the other branches are having more waiting time, right? So this is something that we have done yesterday. Now we'll go a step ahead, and when we will go a step ahead, then we will come to know the beauty of ANOVA. So now what happens is, now we have to look at a wonderful thing here, and that is that we have three branches, all right, and three branches have these many people and they have means, all right. Now suppose, for example, now we have concluded that these three branches do not have significantly different time from each other. That is something we have concluded. But now suppose that if they would have had significant difference waiting time from each other. Okay, let's try to take another example. All right. So let's get to ANOVA and let's get to DVD thing. Now this is another example that we are taking. So here you are. Now, so what happens is, this example is about a DVD player being produced by a DVD company, and it has produced different prototypes. All right. So one prototype is under study here, and the people of different age groups are asked that what score do you give to this prototype of DVD, right? So as one of the criterias of targeting the market for this DVD player is age group, so we would like to see, are different age group people different, have different opinions about this DVD prototype. So that is what we will check with ANOVA. So let's get to compare means, go to one way ANOVA, and here we would say total DVD assessment score, the score which is given by the respondents. We have taken it as total DVD assessment score, and then as we are studying it against age groups, so let's take age group in a factor. So as usually, we will click on to descriptives, homogeneity of variance, and Brown Forsyth and Welch. All right. So say continue and click on to OK. So then we have these many groups, right? And these many groups we have, and Levene statistic here gives a value of 0.720. So what does it mean? So what do we say? Variance of these groups are equal or not? So I would like you to attempt it. So a value of 0.720 in Levene statistics means what? So Rajat and Manjula, any take on this? So what does value of 0.7 tells us? So should we take that the variance of the above groups are equal or they are not equal? So if, can you hear me? So Rajat is attempting. So what do you say, Rajat? So can we conclude looking at that Levene statistic that variance of those groups are equal or not? Manjula, you can also try. No, Rajat, we do not need to check any other values for that. We just need to look at this significance value. See, let me put it in perspective. These both things, though we have discussed it in previous sessions, but since the question has been asked, so let me just very quickly take you through these two things. When you are applying ANOVA, then we have two things. One is Levene statistics and one is real ANOVA, which is F here, right? So Levene statistic is only to check whether the variances of different groups are equal or not. It is as if before getting into a car, you are checking whether fuel is there in car or not. That's it. Levene does nothing. And to do that, you look at the tank, the fuel tank, or maybe you look at the fuel gauge that is given inside the cabin of your car, and just you will look at that gauge only and you will say that yes, there is fuel or not. So you need not to look at anywhere else. So the same way, when you are checking whether the homogeneity is there or whether the variances of these groups are equal or not, you would just look at this figure 0.720. You would not look at anything else, right? So I hope that answers your question, right? So just to reiterate it, a value of 0.720 would mean that variance in these groups are equal because null hypothesis is accepted. So we would say that these different groups have equal variances, and as they have equal variances, so we will go with ANOVA and we will not go with these things. All right. So if even I delete robust tests, that doesn't make a difference to me because Levene says that the variance assumption is actually obliged and the variances are equal. So there you are, that significance value. You will look at this significance value. So having looked at this significance value, we can actually reject null hypothesis of ANOVA, which was that there is no difference between the means of the groups being studied, and hence this null hypothesis is rejected. We would say that the means of the various groups, and means are the DVD scores or the scores that were given to DVD prototype. So these means are different from each other, and they are not only different from each other, but they are significantly different from each other. All right. So this is something which is told to us by ANOVA or significance value of ANOVA. Now something which is very important here. Now I'm getting on to this new sheet and I'm taking this table to this point, right? Now have a look at this. How many groups are these? These are 6 groups. So you can see count is 6 here. So we have 6 groups. ANOVA gave us significance result. This means what? That there is significant difference between means, and these are the means. So if I can actually reduce the decimal points, then these are the means, right? So ANOVA gave us significant results. That means that these groups are different from each other as far as their means are concerned. Now what? Can it be the case now if I take this thing here? So I call it as A, I call it as B, I call it as C, I call it as D, and this F. So I have these 6 groups. So the combinations which I can make out of it is A with B, A with C, A with D, right, and A with E, and A with F, right? So now what I am trying to tell you here is this difference that ANOVA gave us, that these all groups are different from each other. It does not mean, and understand it carefully, it does not mean that these all groups are different from each other. It does not mean that A is different from B, A is also different from C, A is also different from D, A is also different from E, A is also different from F. It does not mean that. It also do not mean that B is also different from C, It also does not mean that D is different from E. It does not also mean that E is different from F. So what we are essentially trying to look at is that the possible combinations that we can make out of this thing. It is not necessary that all these combinations will be different from each other, which means that we cannot say that someone who is between 53 to 59 age group is different from 46 age group and is different from 39 also and is different from 32 also. So the point which we are trying to bring home here is that if any of these combinations, right, if any of these combinations, so we have 6 things here, right? So let's do combination. So we have 6 total number and combination of 2. So these are 15 combinations we will have, like AB, AC, AD, AE, AF, and then we will have BC, BD, BE, BF, then we will have CD, CE, CF. The same way we will keep going on, we will end up with having 15 combinations. If any of these 15 combinations are different from each other, then ANOVA will give you different results, or ANOVA will give you significant result. Alright, I'm just trying to get back to what I've said because this is an important point, that we have 6 groups and we are checking these groups against 1 to 1. If any of these groups, or if any of the combination of these groups are different from each other, then ANOVA will give us significant result, right? So now I do not know whether this significant result, right, whether this significant result which we have got by application of ANOVA is because of which combination which is different from each other. Now just to put the example in perspective, now have a look at this thing, that 53 to 59 mean is 5.29, right? 46 and 52 mean is 6.0 and 18 to 24 mean is 4.95. Now maybe that this group, let's make it yellow, is different from this group, and let's make it say gray. So maybe these two groups are only different from each other and rest of them are equal, because hardly will you find that the difference of 0.3 which is between these two is considered as a significant difference, right? So but this difference of 4.95 and 6.4 is at face value looking very different. So maybe that the people or the young crowd which is from 18 to 24 is different from middle aged group people who are from 46 to 52, but rest of the people are maybe not different from each other. And if this combination, so we were taking this as A and we were taking this as E, so if A and E are different from each other, A and E, and rest of them are all equal, rest of them are all equal, making it green, right? Then also ANOVA will give you significant results, right? So if any one of the combinations is different from each other. So now the next question to be asked is to come to know that which one are actually different from each other, and because of what ANOVA is giving them significant results. So this combination has to be found out, and for that we have in statistics something which is called as post hoc tests, right? Post hoc tests. Post hoc tests are what? They are the tests which checks each combination possible for significant difference, right? This is something that post hoc test does. So to come to know, now we know that ANOVA gave a significant result, we know that these groups are different from each other, but to come to know how these two groups or which one of these two groups are different, let us try to have something else, and this something else here would be nothing but post hoc tests. So we will try to apply post hoc tests here. So post hoc tests are also available into SPSS in under the section of ANOVA only. So we will try to apply post hoc test section. Now for that we have to go back through our SPSS sheet. Now go to analyze, go to compare means, then I'm going into ANOVA. So these two things are already here. So you can see something which is post hoc here. Now before going into, you again have to remember the result of Levene statistic, which is 0.720, which says that variance across these groups are equal. So you have to remember this, and the reason to remember this is when you click onto post hoc tests, you realize that there are two sections into it. One is equal variance assumed, another is equal variance is not assumed. Right? So depending on what was result of your Levene statistic, which is 0.720, which says that the variance of these groups are equal. So when you know that the variances are equal, then you will go with this section which says equal variance is assumed. You will not go with this section, right? So you perhaps will click on to any of these tests which are given here. So these all tests, LSD, least square difference, Bonferroni, SIDAC, Schaffe, all these are statistics which actually are used in calculating the post hoc tests, right? So the popular out of those are Bonferroni, Schaffe. So the literature talks about these two tests being most popular when we are trying to see the difference between means of the various possible combinations across a group or across many groups. When if the case would have been where this value would have been less than 0.05, this value, the cursor where it is revolving, then it would have meant, now suppose instead of 0.720 this value is 0.020, which was less than 0.05. In that case it would have meant that the variances of these groups are not equal, right? It means variances of these groups are not equal, and hence while applying post hoc tests I cannot go for Bonferroni, for Schaffe, because these tests assumes variances to be equal. In that case I would have gone for equal variances not assumed test. Now this section where cursor is revolving, and I would have clicked on to Tamhane's T2 or Dunet's T3 or Games-Hovel. So out of these four, the most popular is Tamhane's T2. I would have clicked on to Tamhane's T2, right? So since this is not the case here, since the significance level is 0.720, right? So I will go for equal variance assumed test, and here I have clicked on to Bonferroni, and hence I will click on to continue, and then I will click OK. And here the same descriptive table is produced because still descriptive was clicked when I have pressed OK. Same Levene statistic is rerun, value is 0.720, saying that these variances across these groups are equal. Then getting down, F gave you significant result, right? So we know now that the groups, these groups are different from each other as far as their mean is concerned, but we do not know that this significant result is because of who are different from who. So to do that we have done post hoc tests, and let's get down to post hoc test. Now this is post hoc test for you, right? So you see what has it done. It has taken age group and age group, two columns of age group. So this is represented by I and this column is represented by J. So age group of 18 to 24, this is the first age group that we have, is checked against the age group of 25 to 31, right? So these two are checked against each other. So the mean difference between them was 0.840. So now what does this do is the Bonferroni test that we have applied is doing what? It is trying to check that the difference which was coming out to be significant in ANOVA, we are trying to see that which combination is actually different from each other. And for that we have tried to check this group with this group with this group with this one, all possible groups. This is the main difference between these two. So is this difference of mean is a significant difference? That was checked and it gave a value of 1.000. So a value of 1.000 would mean that this difference is not significant. Alright, because this value is not less than 0.05. It is in fact much higher than 0.05, and hence we would say that 18 to 24 kids are not different from someone from whose age group is 25 to 31 as far as their opinion about the prototype of the DVD that we gave them to study, right? In the same way, 18 to 24, when it was compared with 32 to 38 age group, the mean difference was minus 0.3. So minus does not matter here because it is I minus j. So it is whatever was the mean for 18 was actually subtracted from this thing. So that gives you minus thing. So minus thing only tells you that the people who were in age group of 32 to 38 were found to be given more score to the prototype and were found to be liking a little bit more than this age group people. Alright. So this was the mean difference. So but was this mean difference different, say significantly different? Result says no. Alright. So then 18, 24, 39 to 45, it says no. So all these combinations are giving you insignificant results, right? All these gives you insignificant result. So then came 25 to 31 compared with everyone. Again, you will find that none of them is significant. So then 30 to 38 was actually combined with all these other things. Again, it is non-significant. Then we come down to 39 to 45, and there you are looking at two groups which are significant. So these two are less than 0.05. So someone who is of age group of 39 to 45 is different from someone who is of age group of 46 to 52. Now these two are different. So these 39 to 45 are also different from someone who is of age group of 53 to 59 in their opinion about the prototypes of the DVD score which were given to them. So now whenever you encounter significant difference, SPSS highlight it with an asterisk. You can see this star here. This is asterisk. So wherever you look at this asterisk, it means that this is significant difference. So this is the beauty of it, in the sense that by application of overall ANOVA, we were saying that all these groups are different from each other, but when we applied post hoc test, we found that that was not true. And then we eventually found out that the difference between someone who is of age group of 39 to 45 and someone who is of 46 to 52, the difference between them actually brought the results of ANOVA as to be significant one. So you can look at it, this mean difference is 8, alright, and this mean difference is 9. So this mean difference ANOVA says or post hoc says is significantly different, and maybe it is because of this difference that the results have come out to be significantly different, right? So this is post hoc test for you. So similar way you can go for this 46 to 52, they are different from 39 to 45, alright. So then 53 to 59, there should also be some significant difference, and there you are, right? So it is 0.04. So this is how post hoc tests actually help us in saying that which combinations are actually different from each other, and because of which combinations have essentially we got the significant results of ANOVA as a whole. So just rerunning through very quickly what I have said and what we have discussed so far, that ANOVA result which is significant does not signify that all the groups which are there in group are actually different from each other. Maybe that there is one combination of groups which are different from each other, and it is because of these groups that ANOVA is giving you significant results. So now you need to identify which one of these groups are actually different from each other. So if I have to put it in perspective, then I would say that you are batch of 3 people. So if you 3 people are, I would say that if any two of you are different from each other, I would say that this batch is different from each other. So now I do not know which one of two are different from each other. That is something that is told to me by post hoc tests. So if I would not have applied post hoc tests, I would have said that this group is actually different from each other, or these people who are actually three in number are different from each other, but I don't know who is different from each other. Maybe that two of you are of similar opinion, but the third one is of different opinion. So we should not also forget the fact that there are some groups which are actually of similar opinion. So this is something which is told to us by post hoc test. Now, does that make sense? So Rajat, any questions, and Manjula, any questions so far in ANOVA? Please tell me, Manjula, if you have any question. So Rajat said, when we say 15 combinations being different from each other, what do we mean? Rajat, what we were trying to do here is, now that we had 6 groups here, right? 6 age groups. We say that we generally said about these 6 groups that they are different from each other. That was the result of ANOVA. Alright. Now what we were trying to see, that this difference which ANOVA gave as significant for the entire groups, for all the 6 groups, maybe that in actually these all 6 groups are no different from each other. So when we talk of combinations, the combination that I was talking about was here. So we would say that, now let me take this thing into account. So I am pasting it up here. All right, then I would say B to C, right? And then I would say B to D, then I would say B to E, right? Then I would say B to F, right? Then I come to C to D, then I come to C to E, and then I come to C to F, right? And then I come to D to E, and then I come to D to F. So these are the combinations that I can talk of when I'm talking of 6 groups. Alright, these are the combinations that I'm talking of. So now what actually we were trying to do, so there will be one more combination which is E and F. So if you can look at this thing, then their C count is 15, right? And this is what combination formula also gave us. So if I can rerun it, we will find that 6 groups we are having combination of 2 are 15. So look at this 15 and look at these 15 combinations, right? So what essentially I was meaning by this is that we have said that these A, B, C, D and E are different from each other overall. So A, B, C, D, E and F. Now this is one group comprises of 6 different groups. Now we say that all generally that these all are different from each other. This is what ANOVA told us. Alright, so somewhere there is difference between these groups. But now I don't know where does that difference actually lie. Maybe that A and B are equal to each other. They are of same opinion. Maybe A and C are different to each other. They are of same opinion. Maybe A and D are similar to each other. They are not of different opinion. But A has a different opinion from E, right? And A is equal to F in their opinion. So if any one of these combinations is different, then ANOVA will give you significantly different result. That is what I was trying to explain. All right. So a difference of A to E. So if I can get back to my output sheet, now have a look at this. 39 to 45 is different from 46 to 52 and 53 to 59, right? So which means this one was 39 to 45, right? So if I can get back to this sheet, so 39 to 45 is different from E, is different from F. Alright, so D is different from E, D is different from F. So D, where is D? D is different from E. So this is red. These are different. So D is also different from F. So this is also different. So now I will make it green because they are not different, right? So now look at this. Out of these all combinations, only these two were different, right? And it is because of this that we said that entire group is different. So now when we have done post hoc tests, we have actually come to know that where is this difference actually lying. This is something which is told to us by post hoc test, and that is what I meant by combinations. So does that make sense, Rajat? So you asked that would that mean that E is of different opinion from A, B, C, D and F? E is of different opinion. No, no Rajat, that is not the case. Now you see, you just have to look at this sheet now. Now we have called this as D, and 46 to 52 are E, and 53 to 59 as F. Now you look at this. It is this combination of 39 to 45 and 46 to 52. So we've called this thing as D, we've called this thing as F, and this thing is different. You see the asterisk. You see the value is less than 0.05. So I'm only talking of this combination now, right? And then I'm talking of this combination 39 to 45 and 53 to 59. You see the asterisk here. You see the value is less than 0.05. This is significance value and this is p value. So it is only these two combinations that are different from each other, but not the case that D, which is 39 to 45, is different from A. It is not different because you see that this value is much larger than 0.05, right? So this is also not different from B, which is 25 to 31, because this value is larger than 0.05. So that is what I have tried to depict here also, that only these two combinations are different. Rest of them are of equal opinion, we would say, as far as their opinion about DVD score is concerned. Rajat, does it make sense? So I hope Manjula has got the point. So that is about post hoc tests, right? So now one more technicality comes into picture when we talk of ANOVA. Now I have to go back to Excel sheet, right? So here what do we do is, many times we realize, now we say, now have a look at this story now. Unless we do not come on to D, all these combinations are of equal opinion, right? So let us see let us see that what does C mean. So C for me is 32 to 38. So can I say or can I treat this entire thing as one group? Now try to understand where I am coming, right? So let's make it blue. So because they are not different from each other, their opinions are different, so they are similar people, so let's make them one group, right? And let us try to see that these two groups are different, so let us make them, which is D to E and D to F. So D, E and F, let's make this group. All right, let's make this as a group and let's call it violet, maybe. All right, so let's make these two groups, right? So now many times it so arises, so when I make these two groups, eventually I'm talking of C is 32 to 38. So I am now talking of below 38 and above 38, right? Now this is what I am talking. Now my comparison becomes this, because I have treated all of them as one group and I have treated all of them as one group, right? So now this thing, if I have to do, then how will I do it, right? Now suppose I would like to see as a researcher that this group, all right, or maybe someone who is still 30 years of age, so let's make it as yellow, or let's make it as orange. I would like to see, are they different from who is above 45 years of age? So now let's make them yellow. So what if I want to see the difference between these two? Are you getting it? So when I'm saying this, eventually I'm trying to see the difference between opinions of someone who is below 31 and above 45. So now this is what I'm interested in. How would I do it? So below 30 would mean combining first two groups, and above 45 would mean combining these two groups. So how do I do that if I have to check this difference, right? So this kind of combinational differences tests, when I have to do, then this can be done in ANOVA by one of the wonderful and powerful concepts of it, and this concept is known as contrasts. All right, so let me write it down. These are contrasts, right? So if I have to see, if I have to make any combination what I would like to out of the group, then I can do it. Now, suppose the previous example that we were talking of branch A, right? Branch A, we were talking of branch B, and we were talking of branch C. Now, what if I want to would like to visualize difference between branch A, branch C as one, and branch A and B as whole? So let's give them this color, right? So I clubbed these two branches. So what if I would like to see a difference between these two, right? So this combination is actually possible by using contrast tests. So getting back to SPSS, so have you understood this thing? What does contrast do to us? Okay, so let's quickly go to SPSS and let's try to do it. So analyze, and then I'll go to compare means, and then I'll go to ANOVA, right? So here are the contrast tests. So I'll click on to contrast. So I will try to form contrasts here, right? Now you remember what we have done, what we were trying to see. We were trying to check the difference between the people who were less than 30 years of age and the people who were above 45 years of age. So for that thing, now let me cancel it up so that we can actually see. So here you are. So I've clicked onto contrast now. So contrast, how they are formed, look at it. So A was 18 to 24. I'm making it 1. Add. So B was 25 to 31. So I'm making it as 1. Add. Right? Now you see the coefficient total. Now have a look at this thing and always keep that in mind. This is 2 now. So I was trying to make one group of these two groups till 31. So I have given 1 to this group which is 18 to 24. I have given 1 to this group which is 25 to 31, and this is what I penned down. I was trying to compare it with these last two groups. Alright, so these two groups which are in between I want to eliminate out of my analysis. So to these groups I will give 0 because I do not want to analyze them, right? So this is 0. And then these two groups I want to see them as 1, so I will make them as -1, right? And I will make them as -1 and add. So this is contrast total comes out to be 0. So what does it do? Now let me show it to you. Continue and press OK. So when I'm pressing OK to it, now look what happens. Now this is the contrast coefficients that I have defined. Try to understand it. So 18 to 24 I have given 1, 25 to 31 I have given 1. Now these two groups I have given 0, and hence they are out of analysis now. So 46 to 52 -1, 53 to 59 -1. Now the sum of these two is -2 and sum of these two is +2. So the contrast coefficient sum is 0, right? So this +2 and this is -2. So when you have two opposite sign equal weight things, so contrast treat them as one group. So the moment I gave sum for these two as 2 and the moment I gave sum for these two as -2, now this is called as contrast number 1. So contrast number 1 compares these two as whole and these two as whole. Now you see total DVD assessment, contrast test. Now it is assuming equal variances. Now for that we have to go to Levene statistic. So what does Levene tell us? This is Levene. Levene tells us that the variances across the groups are equal. So when variances across the groups are equal, then we will look at this row of assume equal variances. So contrast number 1. Now it gave you a figure of 0.116. Right? So 116 would mean that this group which was below 30 years of age is not different from the group which was above 46 years of age, right? So this is something which actually helps us in combining two groups and making it one group as whole, and then try to compare it with any other possible combination. So I could have also done compare means one way ANOVA, clicking onto contrast. I could have gone on to next also, right? And then I could have made it like 1 add, then 1 add, 1 add, so the first three groups I've given as 1, and let's give 1 to fourth group, right? And then -2 and -2. So now you look what happens is, so the contrast coefficients are 0, right? So you'll say continue here and you press OK. So see what happens. Now you have two contrasts, right? Now see, contrast number 1 compares someone of below 30 years of age, because these two are +2 and these two are -2. Contrast number 2 compares someone who is below 46 years of age, below 46 and above 46, because 1 2 3 4 are 4 and -2 are -4, so they makes it 0. So the groups which I have formed here is above 46 and below 46. So look at the tests, and there you are, that total DVD assessment, contrast tests, we will assume equal variances because Levene statistics tells us. So the contrast number 1 was giving us non-significant results, that was telling to us that someone who is below 30 years of age is not actually different from someone who is above 46 years of age. But contrast number 2, have a look at the beauty of contrast now. What contrast number 2 has done, it has made this whole as one group, 18 to 45 years of age, and then it has compared with this group as a whole, 46 and above. So this says that yes, this value is less than 0.05, and hence we would say that when we treat this as one group, 18 to 45 years of age is actually different from this group which is 46 and above, right? Because this is significant. We will not look at this below row because we have not assumed the variances to be different from each other, and that was something that was told to us by Levene statistic, right? So this is post hoc test again for you, so this will again compare one by one. So this was contrast, post hoc tests and ANOVA for you. So right, so Manjula, if you don't want to check all the groups, then you don't do it, you simply do contrasts. Alright, you do not go for post hoc tests, you just go for contrasts. Suppose you want to, okay, you were saying something, you said that I was answering Rajat's query. Oh, okay. I haven't read what Rajat wrote actually, and why do we need to do this? Okay, then Mantra replied, that's fine. So this is how we want to do it, alright? So if one do not want to check every possible combination, then it doesn't take a long to press a OK button, then you have all the combinations. But if you do not want to do it, then you simply go to contrast tests and you give 0 as coefficient to other things. So if you have to look at it like this, then this was A, B, C, D, E and F. So if I only want to compare B and C, I will give it 0, I will give it 1, I will give it -1 and 0, 0, 0, right? So this contrast will only compare B and C, right? This will only compare B and C, and it will actually eliminate these things from our analysis, right? So this is how we can do it. So make sense? Okay, so that is it from my side for ANOVA. So if you have any questions